Good afternoon, everyone. I am Mohammed Abbas, a student of Environment and Sustainability at the DY Patil School of Public Health, and I'd like to extend a very warm welcome to all of you to our webinar, One Degree, Multiple Avenues. I think we can all agree that environment is no longer a subject that belongs only to environmental scientists. Today, whether you're working in healthcare, policy, business, urban planning, technology, infrastructure, research, or even communication, environmental challenges are increasingly becoming part of your profession. Climate change, sustainability, resource management, environmental regulations, and ESG are shaping the way organizations work and the kind of skills employers are looking for. And with this growing need, there is a growing demand for professionals who understand the environment, not necessarily as their only area of expertise, but as an important part of what they already do. This is where we asked ourselves a very important question. If an environment and sustainability degree didn't have, what if an environmental sustainability degree didn't have to lead down just one career path? With our MSc in Environment and Sustainability, we have created a program that is open to professionals and graduates from different backgrounds who want to build a strong foundation in environmental science and apply it to to the fields that they are passionate about. So rather than preparing you for just one job, the program allows you to explore multiple avenues, from climate and sustainability to policy, GIS and ecological planning, conversation, conservation, environment and health, and sustainability communication. And today we're here to take you through what it really means, what these different pathways look like, and how environmental science degree can become relevant to a wide range of careers. To explore this, we are delighted to have with us Dr. Bhagyalakshmi Kalidas, Assistant Professor at the DY Patil School of Public Health. Dr. Kalidas is an environmental science researcher and academic with research experience from the University of Michigan. Her expertise spans environmental microbiology, microbial ecology, and environmental biotechnology, with her research exploring microbial processes and their interactions with the environmental pollutants. With her interdisciplinary experience and understanding of the field, Dr. Kalidas brings a perspective that goes beyond the conventional boundaries of environmental science. She will help us understand how education in environment and sustainability can open up diverse possibilities and connect with a wide range of disciplines and career pathways. Before I begin, I'd like to quickly mention that we will have a Q&A session at the end of the webinar. So as you go through the session, please feel free to note down any questions and share them in the chat box. You will also have an opportunity to ask your questions directly during the Q&A session. With that, I would like to hand it over to Bhagya ma'am to take us through today's session. Over to you, ma'am.
Thank you, Abbas. Thank you for the warm introduction. It's a great day today to be here with you all online. And today we are here to talk everything about our MSc in Environment and Sustainability program. So I'll just quickly share the content. Is, is it visible to everyone? You can put the emojis.
Yeah.
Yes, okay. So before we jump in, I always start with this conversation that I had with my students before, where students from diverse background, it's like be it from BTech, computer science, IT, mechanical engineering, BA, BCom, this one question stands out. It's like, ma'am, you tell me why should I study this environment and sustainability? Okay, so I in turn ask them, what is the reason you're coding? What do you engineer for? Why do you learn the science? And the one common answer that I get from across the streams is, we want to address any identified problem. Okay, and that's the statement that stands out. And they want to be part of the solution. Okay, and I say that you look around yourself. We have our natural systems, we have our environmental systems that's totally overexploited, and the basic necessities of life is all compromised, adulterated, polluted, be it the water, air, soil, the food that we eat. So we have a whole slew of whole spectrum of both persistent environmental issues as well as emerging ones, right? So if you think deeper, you see that each of our human activity is going to leave an impact. Okay, and there was a time when even CFC was not looked at as a pollutant, but it was looked at as a innovation. It was looked at as a discovery. It was looked at as something that will help the environment as a refrigerant, coolant, and if you look at the leaded petrol, it was something that actually helped us to reduce the knocking in the fuel, right? So these were innovations, these were technologies until we found the side effects, the negative impacts of them in the environment. So one thing that was benefiting us in the past has actually impacting us in the negative way in the future. So, which we called it as a solution is not a solution in the future, right? So, even in the case of plastics, we have been using plastics every any direction you put your head to, and you see the use of plastics in different forms, right? And it was also an innovation until we started seeing their negative impact when they started even getting lodged in the placenta, even crossing the blood-brain barrier, right? So these are the solutions to mankind's problem, but then the solutions are not a solution in the future, right? So that is when we are actually entering into an era called sustainable revolution. Just like we had the industrial revolution, we had the agricultural revolution, born out of requirement, born out of the need, right? So we are now entering into an era of sustainable revolution where we not only have to solve an environmental issue, but we also have to solve it in a way that it does not pose as a problem in the future. Okay, so we need a sustainable solution to all these environmental problems. So if we try to look at both perspective of our degree, like the environmental science part and the sustainability part, the environmental science completely talks about the natural systems. How are we into the how are humans are a part of the natural systems, be it the biosphere, be it the hydrosphere, be it the earth systems, how are the biogeochemical cycles changing the carbon cycle with any of our human activity. Okay, so we constantly affect the environment with our activities. It can be anything domestic, it can be anything, it can be a behavioral in a way in which we choose to turn off the lights or go for any clean energy systems for our commute to work or classes. It can be any way, right? So any activity we do, it's going to affect the sanctity of the natural systems. So the natural systems actually depend on us for performing their ecological role into the ecosystem, right? Same way, we also are very dependent on the environment. So whatever infrastructure we have or whatever resources we have right now is sourced out of our natural systems. That's why we call the natural system as the infrastructure, because our infrastructure is born out of the infrastructure that's existing in nature, right? So we are actually interdependent. The humans and the environment is very interdependent, right? So what we see here is while the natural systems, the resources remain the same, we are overexploiting our human population and so our needs. It's not the same. It's a burgeoning throughout. We are not able to keep the pace with the natural resources. So the natural resources are the same, and then the population is exploding, right? So that is when the problem comes. Are we able to meet the needs of our current generation while thinking about leaving something for the future generations? So that is all about sustainability. So it's not only finding the solution for the environmental problems, but also finding a sustainable solution for the problems. So while we do that, I like to. So when we think of sustainable environmental solutions, I like to take this example of this Exxon Valdez, Exxon Valdez oil spill that happened in 1989. That was one of the worst environmental crises that happened in U.S. history. Is anyone aware of it? The students? It was an oil spill that happened on the Alaskan coast, and then the initial containment did not work. It was a failure, and then the oil spill actually spread across the ocean. Okay, so what do you think? I see a couple of them here, a couple of joinees here, like Diya, SP, Tanishka, Shush, Darshan, anyone. What do you think? Let's just brainstorm. So, you have a oil spill there. Who do you think could be the right person to attend to such an environmental crisis at such a level? Anyone? Or any idea like how do you think oil spill could be contained, could be treated? Pooja, are you there?
Actually, it is confined with some boom ladder, and then
Okay.
the maritime team or someone from the seashore authorities, they scoop up the oil, and then it is disposed of in a proper way. Also, biologists are also involved in it to see the effect of oil spillage on the ecosystem there.
That's great. That's great. May I know what's your name?
This is Shivdarshan Ambekar from Tata Motors, Pune.
Okay. Okay. So you're a working professional?
Yeah, yeah, yeah.
Okay, great. See, the reason I brought up this instance is it's historically worst environmental scenario that we had experienced. And if you see the solutions to such a oil spill at such a large scale, you will see that there were mechanical skimmers, like you had mentioned, physical containment, right? So mechanical skimmers were used, and biological scientists were involved to assess the biological impact of hydrocarbon, such as the petrochemical oil, right? Fuel. And it's not just that they also faced a lot of herring population loss and loss in livelihood of the fisheries population. And there were some solutions from the scientists that were also from the chemical engineers, where they used made use of some dispersants, so to disperse the oil so that it will be like small aerosols, and it can be easily degraded by the existing in situ microorganism. So that was also one of the ways in which they attended to the problem at hand, right? So if you see, look at that. So you have the environmental chemists having the dispersants as one of the solution. You had the biologists to assess the impact, as well as to rope in the in situ microbes that can actually that are known to degrade the hydrocarbons. You had the mechanical skimmers. That's the technology involved. So you have a whole plethora of different diverse group of people coming into the picture, right? So that is why I say that it's a very interdisciplinary area, where having just one person, having just a microbiologist will not work, having just a climate science person will not work. So that's why we have devised this course in such a way that you have all components of these so that you can actually gain all the skill sets while you go out at the end of your 2 years, and then you will be referred as an asset to the wherever organizations you go in, right? So you have a whole lot of areas and sectors where you can be involved, where the involvement is very necessary. And even after this, one thing you might not have thought about is how it also drove to the beginning of policy changes, policy shifts. Okay, so it also brought about Oil Pollution Act that was in 1990. So 89 the disaster happened, and in 1990 you had the Oil Pollution Act. So what to do about such disasters, right? So you have the policy people coming into picture. You have the environmental law and ethics to actually deal with such lapses in regulatory issues or compliance issues. So you have all of these that have to work together to address that particular environmental situation, right? So you need the solutions at the intersection of science and earth systems, governance, climate science, you have ecological planning, all of it. So this is kind of the foundation for your MSc in environment and sustainability. Okay, so you have also environmental management. I think we have Dia, who has done her undergraduation in environmental management, where there are components on environmental impact assessment, and there's also environmental management systems, where you have the ISO 14001 standard track the sustainability goals. So how the businesses are orienting their activities towards meeting with the sustainability goals, right? So all of that. So it's a whole spectrum, so that you are not at a loss when you, at the end of completion of this MSc, you are going to be a whole new researcher. It can be a researcher, it can be a corporate person who can give their ideas, who can be a part of decision making, so be involved in the policy making. So all of that is possible, right? Yeah, so there was a time when it was just a mandate for the businesses, organizations, corporates to actually check out the checklist box where, oh yeah, I have some activities that are working for the environmental development. Okay, so I'm doing something for the social development. So all of that was a necessity at that time. But here, so that was like compliance. So only if you check that box, you are going to be, your business is going to be allowed. Okay, but now there's no option. Like, there has to be the sustainability goals have to be met for the business to sustain, not as a compliance but also as a necessary. It's not a nice to have option for the business, government and development priority anymore. Okay, so these days you will see that there might be different industries that are relying on so like I said, we are all depending on the environment for sourcing our raw materials for our businesses, for our activities, and then they are vulnerable to all these climate risks, right? So that's why these days the businesses also have a wing that assesses the businesses how they progress with the climate risk ahead. That's there in broad daylight, right? So industries actually need climate risk analysts. Industries actually need climate data analysts to actually convert it to meaningful information that'll be important to that is necessary to translate it to business models, right? So they have a lot of openings on sustainability manager, ESG sustainability compliance managers. So here the workforce is actually workforce that is on climate risk assessment. It's a huge demand. So I would actually say that this program has been started to meet with the demand. Okay, so that is existing currently. And if you see the upcoming in the near future also, by 2047, that's the estimate we have, how about 35 million the green jobs are going to be increasing by about 5 times, right? So you have all these economic opportunity created by India's transition sustainability, India's transition towards renewable energy, transition towards biogas, transition towards we have the E20, right? So we are slowly. So we didn't start with E20. So the research happened with E5. Then moved on to E10, E20. So that kind of progress, that kind of shift towards sustainable industries, low carbon emissions. So all of that has actually increased the green job opportunities in India, and it is proposed to exponentially increase. Okay. And if we look at the, like I said, it's born out of demand. The program has been started because there's a huge demand, and there are not enough experts to deal with all the environmental issues at a hand. So there's a huge demand supply gap that can be filled once many of you actually make it through this degree program. So there's a huge scope for everyone that completes this MSc program. Uh, yeah. So, to give you a more elaborate idea about the structure of this MSc program, so we have it through 2 years and it's a semester base where each year is broken down to 2 semesters. So you have you'll be having the semester exams at the end of semester. So and it'll be covering about 80 credits, so 20 credits in each of the semester that you'll have to successfully complete and it's right now open for in person full time undergraduates, right? So you if you have done you completed your undergraduation bachelor's degree in anything on environmental science, biotechnology, you have it on basic sciences, physics, chemistry. So if it's architecture, so if you have on any engineering streams that's like the environmental management, so you're more than welcome to join and take your career further through this MSc program. And we have devised it in such a way that it's wholesome and it's mostly interdisciplinary. GIS, you have the climate sciences part, you have the earth sciences part, you have environmental policy, you have environmental justice. All of that is covered so that you are not at a loss at the end of this 2 years. Okay, so this is probably one of the most important slides for the students sitting here today. So I have a bachelor's in environmental science, but that's not enough. Okay, so why do I want to do my master's? So imagine a scenario where you have a flood resilience. You want to design a flood resilient city. Okay, so you would ideally need, like I said, it's going to need at an intersection of engineers, scientists. You'll need the GIS specialists. We'll have to rope in the planners. We'll have to rope in some policy makers. So it has to be these different sectors when you have to get the sustainable solution for the identified problem. So really these days we don't have that boundaries anymore. It's very narrow, it's too thin. So if you have been physicists, they have also working on clean energy systems. Electrical engineering, people work on clean energy systems. You want to have the solar reflectors that actually reflects the most, about close to 100% of the solar energy. So that's going to be the physicist that's going to help us in getting the most energy efficient system, right? So it's going to there's no one entry point. So I would say it's a infinite entry points where if you have been having your background in geography, so you might want to take it forward with focus into GIS, into mapping. So how to do a heat map of the existing forests, how to do a heat map of the existing deltas. Okay, that are more vulnerable to this sea level rise and climate change. So it could be something that can extend your area that you have been doing in your bachelor. So it's like it's not hard and fast. It's like we have this flexible system where you can actually take it to the next step in the area of your interest, right? So we have the program, like I said, it's a semester-based program, 2 years with 4 semesters included in the 2 years. So the first semester we have structured it in such a way that since many will be joining from diverse backgrounds, so it might be a geologist, it might be some policy person, it might be an engineer, it might be an architect. So it can be anything, any background stream that you might be in. So we want to bring you all into one platform. So we want to have you all having that idea about all the areas, so be it climate change, earth sciences. So you need that common foundation, so which will be delivered to you in your very first semester. Okay, and then in the second semester, that is when you actually get to develop your professional identity. So you want to make it, you want to actually focus your masters and your future area, whatever career path. into climate science, or you want to have it in planning, or you want to have it in sustainability. So this is the time you get to pick one specialization out of the six specialization tracks that will be offering. So we'll be discussing that in the next slide. So so in the third semester, that is when you get so everything cannot be dealt with inside the four walls. Everything cannot be discussed through PowerPoint slides, right? So the third semester is structured in such a way that you get to go into the field. So sometimes it's something that you'll have to come out of your comfort zone because you have to get your hands messy. But that is necessary when you want to really address a problem like what I mentioned for the Exxon Valdez. We had a similar one, Bhopal gas tragedy in India, right? So somebody has to actually measure what's happening. What are these toxic gases? So how is the measurement done in the field? So such field level immersion is very essential. And in the third semester, you'll also have to do an internship with either the government organizations or the corporates. So you have all your options. So either you can do it, you can find the organization or institute on your own, or the university will guide you or how to reach out to the right place, right people to work on the area of that's close to your heart, right? So ultimately it has to be something you're doing something of your interest, right? So we want to make sure that by the end of third semester you have that field experience, so you have the practical idea about, okay, if I have to work on bioremediation, or if I have to work on policy shifts, what would be the first step, what would be the second step? So you will get a chance to actually be in live projects. Okay, so that will be the semester where you will have practical idea knowledge, right? And in the fourth semester you will have the capstone dissertations. That's a essential part of your successful completion of masters. So in the common foundation you have the earth systems and boundaries. So this is something, like I said, it's to set everyone on the same stage and then to brief everyone, so it will give you an idea about all the tracks. Okay, so I have made sure such that nobody loses out on what is there in the other track which I'm not really interested, but I would really like to have an idea about it. Okay, so that is when we develop this structure where you have a bit of understanding about each of the tracks. Okay, so here's the most interesting part where you get to choose your area for your specialization, right? So this is where, like, you have your green infrastructure, ecological planning. If you want to be part of any urban planning, or if you want to make sure the building or the infrastructure that's developing in your region is actually complying with the sustainability goals or something like that. And the other areas are like environmental policy and governance, climate change and resilience. So you have all these six ones. So whichever, it's up to you based on your interest where you want to take your career forward, right? So in environmental, in climate change and resilience, so you see that a lot of factors are emerging that was not existing before. So you have the heat and air quality. You have things on the health. How does there how allergens come up and affect the health during a thunderstorm? So how are the vector-borne or the waterborne diseases are going to be having a different geographical distribution? Okay, so all of that changes. Or how is this, what do you call as climate change? So we'll start with that and slowly move towards how the climate change has its impact on diseases, has its impact on the nutrition. And I constantly tell this to my students. So when we talk about climate change, it's always a disproportionate effect. Okay, so the way it's going to affect me is going to be different from the way it's going to affect you. Okay, so that's why we always study or identify who are the vulnerable populations, and then we do the risk mapping, right? So there are a whole set of how to address or how to go about climate resilience. So it can be in terms of agriculture, it can be in terms of fisheries, so it can be in terms of I want to be somewhere in the team that reduces the emissions. Okay, so I want to be in net zero strategy. So these are some of the areas that will be present in the track on climate change and resilience. And there's also the possible job roles that have come up. So these are, if you look up even today in any of those job opportunity portals, right? So you will see that MSc in environment sustainability, you have huge opportunities in Mumbai itself. So if you're from Mumbai, so and it's across India, so you have the requirement, huge demand for climate analysts, climate risk analysts, climate data analysts. You have the mitigation. So how to assess it, how to mitigate it. So, project level assistance, so be it in the government sector or in the corporate sector. So, you have it all on out there for you to choose from. In environmental policy and governance, that's our track two, where like I said, any environmental disaster you get into, and you always see that after it happens, you have a law that comes up that's born out of it. Even for the Bhopal gas tragedy, you saw that it happened in 1984, and then you had the Environmental Protection Act in India. That was 2 years later, 1986. You have the Wildlife Protection Act in 1972. You have the Water Prevention and Control of Pollution Act in 1974. You have a whole lot of laws that are actually trying to protect the environment, protect the natural systems that we have. But then, if you're not familiar with the policy, if you're not familiar with the law that's existing, we will be at a loss even if we have these existing. Okay, so a lot of times it has to be fought for. Okay, so that kind of environmental diplomacy is something that you will be introduced to in this particular track. So, like I said, in green infrastructure and ecological planning, uh, it's something about how to design your city, how to design your living space, how to design your ecosystem. Okay, so a lot of times when we talk about urban heat islands, we have the green infrastructure as a solution. Okay, so that is something like how you can actually have your infrastructure made out of sustainable materials that actually does not absorb as much heat as the other conventional ones, right? So you don't want the building to absorb a lot of heat in the summer, and also you don't want the building to lose a lot of heat in the winter. So that's all about how you can have the infrastructure made out of sustainable materials that has all these properties. Okay, so when I say infrastructure, it's not just the buildings, it's not just a built environment. It can also be infrastructure like having the wetlands, having the mangroves, having the natural ecosystem in place. Okay, so where these also protect us from the sea level rise. These organisms, the macroorganisms, the coastal organisms actually have a way of tackling the sea level rise. So those are something like your nature-based solutions. So this track will actually help you identify what are those systems that are the built infrastructure as well as the natural infrastructure, and how you can map them. Okay. And the fourth track is on conservation and biodiversity. So I think everyone is familiar with the Project Tiger, Project Vulture, right? So it's a national success when the tiger population was dwindling. Okay, somebody might said, why tigers, right? So it was of great importance for the ecosystem, not just for the ecosystem, for the whole population, right? So when the population was dwindling, and the government took an important measure of actually having the corridors planned, and because their population actually determines, so they actually protect the whole forest, they actually protect all the raw materials that are there in the whole forest. So they are considered like both as a keystone species as well as the umbrella species, right? So this is all because we have our raw materials coming out of the natural systems, coming out of the forest, coming out of the earth systems, coming out of the water. So all of that has to be protected. Okay. And there's a huge value that is present in the biodiversity. Okay. There's a lot of value. It can be the options value, it can be the ecological value. Something like presence of the tree helps in retaining the soil moisture or prevents it from soil erosion. So things like that. So biodiversity assessment is a lot of is one of the key feature in any of the projects also. So any project comes out, people have to do the assessment. So I recently heard that the Parsik Hill, there's a lot of mining happening, a lot of blasts happening, and environmental activists really want to do a biodiversity assessment and then present it in front of the government so that the hills can be protected, right? And a lot of times we have the environmental impact assessment where they will assess the ecosystem how it's going to be changed because you have your economic development coming up in that region, right? So a lot of times that is very essential for economic development. That's very essential to make sure biodiversity assessment is very essential to make sure that we retain the population and then make sure we have a healthy population of the wildlife. It can be the microbes, it can be the flora and fauna, right? So for that, if you want to monitor, so again, you will be needing the GIS, you will be using that to do the ecological monitoring. You'll be recently I've also heard about rewilding. Okay, when you know that a particular ecosystem is completely degraded. Okay, so you want to bring back its ecological benefits and bring it back to its healthy state. Yeah, actually, even in the Yellowstone National Park, I'm not sure how many of you are aware of this. The government had extirpated the wolf population because it was a predator, and they actually started a predator control. They thought if the wolves are not there, the herbivores will be good, right? And then after they were extirpated completely by the end of I think 1950 80s, they actually saw that the ecosystem is completely degraded without the wolf, that they saw it as a unwanted predator. And then eventually the government had to bring back the reintroduce the wolf population there. Okay, so we have taken the ecological services that the environment natural systems provide for granted. And it's a very late realization when we see that the species is gone and we are actually losing a lot of the services that we had when it was present, right? So that's why biodiversity assessment is very important before any economic development step is taken. And it's also important for decision making. So this is one track that's very close to my heart. It's environmental microbiology and bioremediation, where I have done my research completely on this, where I have tried to use the methanotrophs. That those are the bugs that actually feed on methane that we call as a greenhouse gas, right? So a lot of microbes are not just the microbes. So you have the macroorganisms, also like the macroalgae, seaweeds, all of them. So all of these organisms actually are used. The natural system always has a solution on its own. It's just for us to identify and discover. So recently, if you've heard, we had the fungi species that was identified to degrade the plastics that were there in the Amazon forest, right? So, but who found it? It's the environmental microbiologists, right? So there has to be, so we will have to constantly learn from the nature. So it need not be always in the macroscopic area sectors, but also at the microscopic level, what you can see under the microscope, right? Because if you see the methanotrophs itself, they are known to reduce the methane emissions by 80% even before they are emitted from the soil. okay, such is their conversion rate for from methane. Okay, they can degrade. So all these degradations, you will see that instead of, you will have an alternative with the physicochemical methods that ideally would require high temperature, pressure, all those conditions that are very energy intensive, right? But with the microorganisms, if you can actually understand how they work, you can put it to good use. It's like the pets we have, right? So we are trying to use them. It's also like the farm animals, right? We are trying to use them into our human activities, right? To make our life easier. So that's something like the microorganisms are also constantly working in the environment, just that they're not visible, right? So they are very much part of transformation. If you look at the fermentations, so we have Saccharomyces cerevisiae, right? So the bioethanol production. So you have all the biomass, that biomass residue. So after the sugarcane is used, we have the bagasse, right? So that is actually used for making the bioethanol. So at this age of sustainable revolution, there's nothing called waste. So all of the biological matter is actually whatever, even in the solid waste management, this waste is not considered as waste. It's actually considered as wealth, right? So you will just have to identify the right set of microorganisms that will do the conversion for you at the expected rate. Okay. So all of these will be covered in the track on environmental microbiology and bioremediation. So the sixth track is on sustainability, communication, and behavior change. So once you have seen all the examples, right? You have the climate sciences, you understand earth sciences, you know where the degradation is happening, why it is happening, why you have the Delhi air quality going so low. You have evidence is coming up like how many metropolitan cities, the ozone levels, the ground level ozone levels are super high. That does not follow the standards, air quality standards, right? So you have such an idea, but then who is going to communicate it to the wider population, or wider or even give a advocacy on that? So what can be done, or why it is? What are the sources? What are the consequences? So there has to be there is existing sector how you can actually do the communication on sustainability, how you can involve, how you can have the community engagements, so how you can give the correct facts to the right set of people. It need not be the common people. It sometimes has to be advocated to the government officials. It sometimes has to be conveyed to the corporates, right? So that is where you will have a lot of idea on how this scientific knowledge can be translated in a way that the wider population can uh, assimilate, right? So this is on field immersion and internship that will be in the third semester. So this is one of the areas that I really like to emphasize to the students. Yeah, you need to come out of the classroom setup, and then you will have to have your hands messy, and uh, it'll give you a lot of broader perspective, broader directions on sustainability consultancy, education and communication, policy and diplomacy. So it's you need not take it as an internship as such. So uh, uh, you can think of it as a step towards or a buffer zone before you get into your actual job. Okay, so that's why we have worded it such a way that it's like a career oriented internship. So you have your liberty to actually approach a organization, and then you can do the internship in a period that is in an area that is that you find it important for your career, right? So you have the sustainability field lab that's mandatory, and you have the career oriented internship in the third semester. And the final semester is all about your capstone that will define your area of expertise, that will give you an identity So even there, you have the flexibility of choosing among one of these three options, where you can either do it as a research thesis. So you try to find a problem statement, and then you try to work on generating the data, and then analyzing, reporting the data, and presenting the data, right? And the second option is, of course, you can do a consultancy project where you have the liberty to approach any organization or institute with the same kind of specialization for a practical challenge, right? So it will be like a work that's an extension of your previous internship process. That could also happen. Okay. So as a option three, you can also do. So we have an innovation hub within our school, within our university, which you can actually make use of to complete your capstone research. So you can have your own ideas translated to something, some 3D model or a prototype, or it can be a planning or a framework that you can develop, right? So all of those options are given to you to choose from, of course. So these times I keep hearing this often, like the students first they ask like, why should I take it, and then what's going to happen to me once I complete it, right? So you have a whole plethora. So you open any of the job portals, you put your degree, put your specialization, and be it government, be it the NGOs, you have the TERI, that's the Environment Research Institute in Delhi. You have the government organizations, the CPCB, MPCB, for the Maharashtra board, the pollution control boards itself. The moment you open the CPCB portal, there's a whole lot of opportunities waiting for the masters in environment students. So just this morning, I was just trying to get some data from the CPCB website, where they actually offer core government scientific officer positions. They offer scientist B role for conducting environmental research, formulating national pollution standards. Okay, so I'm not sure how many of are aware. So that's why I'm trying to. This is kind of environmental education, you'd say, environmental education and awareness. That's also part of one of your tracks. So the position they have advertised has these roles of actually managing hazardous waste guidelines, overseeing cross-state or river or air quality monitoring networks. So all of these are there. And for freshers that come out of immediately out of their masters, they also offer senior scientific assistant (SSA) roles, where you will have to supervise lab experiments, or if you're not very a lab person, so you have an option of they have given a whole lot of roles for a person who has completed their masters in environment and sustainability. And this is at the senior level, and at the junior level, which is also open to the BSc students, bachelor students, right? So it'll be something like monitoring a localized training or pollution control experience they'll get. So it's not always permanent jobs. You always also have options. So they do advertise also for contractual and project-based schemes, which I came across today was some schemes on national targeted national missions like National Clean Air Program, right, NCAP, and also on Namami Gange, right? So they are constantly hiring. So like I said, there's a huge demand supply gap, and we need experts to address, and people are looking forward to hearing from you, from your expertise and from your focus areas. So we need more of you people to actually get on the scene, right? So our school also has a career and placement cell. So it'll walk you through, or even we had a mock one where from the CV making, and then how to actually answer the interview questions, like the moment you enter, greetings, and then the formal attire. So all of the simple things as well as technical stuff. So how to present yourself in front of a panel. Okay, that's looking forward to your valuable answers, right? And that's going to evaluate you for that particular job role, right? So, and it also actually helps you with the internships that's there in the third semester. So you have a good career guidance cell and placement cell. So we currently have collaborations with international academic and research connections. So we have, I think recently some of our students went for this Eco Network um, meeting where which happened for about, I think, 2 weeks, 3 weeks. I think Abbas himself was part of that. You see, he and along with his peers, three of them. And we have UNICEF. We have currently a TDR project that's actually a consortium, research consortium comprising of WHO, UNICEF, United Nations Development Program, World Bank, all of that linked together to assess the climate variability and infectious disease hotspots in the Mumbai metropolitan region. Okay, we have the project ongoing in our school where many of our students are actually interning also are part of the project in as key informants. So a whole lot of activities are going around that. Yeah, we have the collaborations with, like I mentioned, TDR. We have the University of Aberdeen. We have where we have the dual degree in MPH. We have McGill University where we have the collaborations. We have UNICEF Maharashtra. All of that is there. So, collaborations is something that's actually necessary when you want to address a very big problem like the climate risk assessment. You would actually like to partner with people who are already working in, if you are venturing it into it newly, right? So, such collaborations will fetch more relevant, sustainable solutions, which is very necessary at this current scenario. So these are multidisciplinary faculty, I would say, where we have people from climate sciences, we have architects, we have myself, environmental biotechnologists, we have environmental chemistry. So we have biostatisticians, we have epidemiologists. So we have all of our faculty that are working towards all the programs and divided into four divisions. So one of that is the environment sustainability divisions where we have the BSc and MSc programs, and we have the other ones epidemiology and population health, health systems, policy and governance. So, whenever we have the students working on projects, internships, so it's very common that, like I said, there are no boundaries existing in the current times. We get to hear the expertise or their opinions of the faculty. So, you get to actually tone down or refine your research or your internship work with all these, the faculty strength, right? So these are some pictures from our recent field immersion activities where students had a stay inside Funsud, the natural Funsud. What is that? Wildlife sanctuary, yes. And it was like the students learned a lot by the whole thing, experiencing it, the biodiversity there and how the assessment is done. So it was a completely immersion activity that they got to learn firsthand by seeing, looking at it, and experiencing it in real. We also had a summer program for 3 days where we had participants from across the state, and then we had students, 10 standard students, 12 standard students. So we had participants doing their BBA, and we had some prospective PhD candidates where they all had a nice sense of what the school is about and what are the different programs. And this was something on our summer immersion for the environment and sustainability program, where they actually went to the field, tried to assess the pollutants that were actually choking the lake, that was choking the wetlands, and they also had a view of our flagship. What's that? Flamingos. So I think we have the flamingo. The video is not running, I think. Okay. So this was captured by our students. but participated in the summer immersion. Yeah. So with that, I'll take any questions.
Yes, so there's some questions in the chat box. The first one is by Mr. Shivdarshan, who's asking if it is a full-time course.
Yes, it is a full-time course. But we do have an option. We have developed a postgraduate diploma option where working professional can also do. It's a 1 year thing, and we are trying to see how it works for the working professional because they're not always available, right? So we are having it open. Yes.
The next question is if there are any placements at the end of the second year.
Placements at the end of the second year. Okay, I've not thought about it. But seriously speaking, so our third semester is completely on the internship. If you think you can approach the thing, but you will have to have the complete the mandate, university mandate, and the program mandate of submitting your capstone project, which can be
Oh, it's end of
the
second year. Yes. May I interrupt? End of second year is a placement year, isn't it?
Was it end of second year or second semester?
It's end of second year.
Okay. They want to know if there are any details for the 1 year diploma course right now, and if yes, the fee structure. So, we can actually connect you with our admissions team, and we will share all the details with you with the number you've registered with us. Also, there's one more query asking if we could elaborate more on the diploma.
Uh, I think you saw the structure for the common foundational courses in the first semester for our MSc program. So that would remain the same for the PG diploma, and the specialization part, it's up to them to choose one of the 6 tracks. So that's the structure we have right now.
I'm Dr. Shweta. To add to what Dr. Bhagyalakshmi had mentioned earlier about the placements and internships, the school has, tie-ups with various organizations which are working in the area of environment and sustainability. And through Dr. Bhagyalakshmi, we are in the process of, expanding our networks, and we have expanded a lot. The school also has a grant from WHO, the TDR project, where we are looking at climate change and vulnerabilities in MMR region. So the basic crux of what I'm trying to say is through the internships which we source and tailor it according to the skill sets or needs of the students who want to work in specific areas or concentrations of environment, as was just presented to you, or any speciality, we fix your internships, and during those internships we make sure that whatever skill sets we provide you at the school level, be it the professional skills, be it the soft skills. So for developing soft skills or other skills which are quote unquote not taught in the classroom, we also have a workplace readiness program. We prepare our students to polish their already present skills and also provide them with new skills. In that process, we also invite HRs or people of stature from organizations which are relevant to us, and fix mock interviews with the students. We give them a job description and they have to prepare accordingly and sit for those interviews, and then we give them tailored one-to-one feedback. And we are very happy to announce that our master students who are doing public health, and they have been, most of them, they get absorbed during their internships or right away when they pass out from the school. So it's a very structured mechanism from the very first day of your school, where we guide you through practical theory internships and then make you ready for the placements. So I don't think you will have to worry for placements. The school has a record of 100% placements for our other master's courses. So yeah, I think we are you'll be you'll not find any difficult. Yeah.
So we have some questions from the registration forms. So the first question is the degree course in accordance with NEP? And if so, what is the age limit and eligibility criteria?
Okay. Yeah, it is following NEP 2020 and also the requirements, adhering to the requirements of sustainability goals. And we, as such, don't have age criteria. And what was the third one?
The eligibility.
Eligibility criteria. So you should have 55% aggregate in your bachelor's. So your bachelor's can be anywhere in environmental science, or it can be in any of the basic sciences, engineering or architecture. So yeah, so we have set it as 55% aggregate. Yes.
I'll just come in here. You can also have it from any social sciences. We do believe in, opening it out to all streams, and we ensure that, those who may be from a different stream, we bring it to them onto the same standard by having specializations with them. So it is open. So, but then having a maybe a science degree may be a little more, desirable or beneficial. But however, it is open to other people as well. Yeah. Thank you.
There's some few more questions if um what yeah, so one person had asked if this is a good course to switch sectors.
Yeah, that's interesting. Like I said, it's multidisciplinary. We have had queries from different sectors on how they can take up this course. And because we right now have it as full time, and we said we will be that time we said we'll be having the PG diploma also for working professionals. So they did not have the background in environment, but then because of the environmental compliance, because of the emerging ESG compliance that's there right now, so they actually, as a for their career perspective, they actually requested that they would like to come into this sector as well. Okay, so that's the requirement out there. And also, if you see, you have a lot of biogas plants coming up. Even the Reliance is planning to set up about 500 biogas plants. So it's at the intersection of engineering, technology, and biological sciences. And I would highly recommend, there's a huge scope outside once you have this degree in hand. Yeah.
Any more questions? Thank you, Dr. Bhagyalakshmi. I think it was a very informative session, and I think you answered most of the questions. If you have any further questions, I think most of the participants you registered for it, you have our details. We have your details. You can write to us. We'll get back to you. And if there are more questions which you think left unanswered, or you go back home and reflect on it, we'll be more than happy to answer those for you, and our admissions team will get back to you. As we close to this session, I think I wish you all more learning. And apart from looking at it from a perspective of, gaining a degree, we should also look at it from a perspective of, imbibing it in our everyday lives. So each of us can make a little difference. So uh, thank you so much. Thank you everyone for joining once again. Thank you, Dr. Bhagyalakshmi.
Yeah.
Have a good evening.
Thank you.